Might as well. Maybe I'll spend a bit more on precision measurement tomorrow, tolerance and all that. I'll talk that way. You're prepared. A community group is building birdhouses. State the type of triangle that is shaded in the diagram. Isosceles, there you go. Yes, obtuse. Obtuse because of this, right? Because of that, it's obtuse. And then it's isosceles, obviously, because the two sides are the same. If this had been a 60 up here, it would have actually been equilateral, because if this is 60, the other two are also 60, right? Because these two sides are the same. So just be careful. State the measure of angle C in triangle ABC. So they want this one here. So I'm just going to go. C is this one. This is 120. But this angle is the same as that one, right? So we're going to say that angle C is simply going 180 minus the 120. And then we're going to split that in half. So what is that? That's 60, right? 60 divided by 2. That's 30. So 30 degrees is the angle C. All right, next. Bartholomew is solving a math problem involving a truss bridge. The 30-meter bridge is made of 5 equilateral triangles. It's probably very important. The 30-meter bridge of the same size and has 2 braces as shown in the diagram. So the braces are, I guess I'll use a different color for that one, right? There's one here. Yeah, and there's like 1, 2, 3, 4, 5 equilateral triangles spanning it. State the measure of angle A, this one, 60, right? Yes. That one, it says state, that's usually a giveaway that it's going to be fairly simple to get. And now calculate the length of the brace. Let's see here. This is, how can we do this? How can you break this down? Well, you obviously need, let's make a diagram here. This is the brace, this is the dashed line here. And then I'm going to use this and this, right? These two here. You see where I'm going with this? Trigonometry, right? We're in trig and geometry. This is the brace. This side is the same as that side. Let's see here. Is there any way we can get numbers here? If these are the same and it spans over 30, right? We can just go 30 divided by 3. And then we get, right, each of these chunks separately. So I'm going to go 30 divided by 3, that's 10 meters. And I will use a highlighter for that, right? So 10 meters is this one right here. And therefore, because this side is the same as that side, right, we have 2 sides on our triangle. Let's bring that in here. We know that this is 10 meters, and we know that this is 10 meters. And the brace is that. They want to know what that is. That is like X for us. How can we get an angle in here? Supplementary. See, do you see this straight line down here? So let's just, on our diagram, just bring this out. Yes, this is 60 for us. We know that because the triangle that's beside here is equilateral. and which means that the inside, that's why I kept on doing questions like that, right? This is 120 degrees. I think this is so much work for 2 marks. I have to say I disagree. And they have changed their marking scheme. I can guarantee you it'll be 3 marks nowadays. Okay. So what's this? What kind of triangle is this? It's an isosceles, but what can I, sorry, which law could I use to figure? Is there a pair? No pair, right? Cosine, side, angle, side. So to get x, I'm going to go x squared is 10 squared plus 10 squared minus 2 times 10 times 10 times cosine of 120. 100 plus 100 minus 2 times 100 times 100. Oh, no. Times 10, right? Slow down. That's root of 300. Take the root of that. 17.32 meters. Yep. There was a way to do it with sine law, because just like from the previous question, guys, we had an isosceles like this, and we ended up with 30 and 30, correct? So then you would have had a pair, so it is possible. How's the next one? Is it easy? Oh yeah, multiple choice. Let's do this one and then we'll call it. Identify which of the following is a property of a kite. The length of the opposite sides are congruent. Opposite angles are congruent. Diagonals are congruent. Diagonals intersect at a 90. Well, we know that diagonals are not congruent, right? There's a long and the short. Opposite angles are not congruent. Only these two are, right? Only the ones that are connected by the short, but these two are not. So that's also a no. Length of opposite sides are congruent. This side is opposite to that side. They're not congruent. So diagonals intersect at a 90. I hope you remember that. That is definitely a kite. Okay, so D is your answer there. Thank you, guys.